No, I think you want.
Where's the thing? Where's the doodah? Have we got a doodah? The clicker. Ah, there it is. Hello. Hello, hello, hello. Hello, hello. Testing, testing. 1, 2, 3. Can everyone hear me okay? Hello, Andy. Shh. It's gone 2. We should start. Thank you. We're just handing out some notes. This is not notes of the talk. This is notes that you can take away, and there's a bit more information and websites and information like that. And if there aren't enough to go around, if you'll be so kind as to photograph them and hand them to people who want them.
I've got to introduce people.
Oh, okay.
I've got to say hello.
Okay, go on then.
Good afternoon, everyone. Is that working?
It's
Okay. Can you hear me? No? Closer. All right. Can you hear me now? Yeah? Wow. Okay, good afternoon, everyone. Just to check you're in the right session, this is going to focus on permaculture design for water-retentive landscapes. Right? If anyone's in the wrong route, you can leave. It's happened before, but I'm delighted to see such a large crowd of friends and new acquaintances. We have 3 speakers today with very complementary perspectives on permaculture design for water-retentive, resilient and productive landscapes. I'll just start off by giving a little bit of an introduction of context, and then we'll have the presentations, 10 minutes. There'll be a panel discussion, and after that I'll open it up for questions and answers, and questions from the floor. So I think, putting things in context, it's necessary to remind ourselves of how much water management is in crisis everywhere. And if we take the UK context, given that we're here in this country, the UK is facing a water crisis due to a combination of factors that include climate change, of course, but also overconsumption and water distribution issues. I just want to highlight 4 facts which have a bearing on this session. The demand for water is outpacing local supply in some regions. Apparently, the Environment Agency has warned that England, not the UK, but England would run out of water by 2040. The second is that the UK is experiencing droughts more regularly and increasingly with climate change and rising temperatures. But it's also experiencing more rainfall and floods, as we've heard over the last few weeks, all linked with global warming and the atmosphere holding much more moisture with the additional heat it has trapped. The third point is that in 2020, it became apparent that no river in England or Wales was classed as being in good overall health. We're really at a tipping point in terms of freshwater quality. Sewage, urban pollution, agricultural pollution, industrial pollution all contribute to the problem. And I just want to highlight 2 examples. The UK sewerage system is in a terrible state. It can't cope with the combined problems of increasing water consumption, urbanization, and climate change. Apparently in 2022, there were about 400,000 discharges of untreated sewage in UK waters. And industrial farming practices is adding to the pollution load. The production of maize and poultry, for example, often pollute rivers with pesticides and manure. For people involved in research or trying to tackle these problems, it's striking to see that there's a very narrow sectorial approach that prevails when it comes to water management. And this is manifest in universities and natural resource management bureaucracies. Sectorial, narrow approach in which water is considered in isolation from the wider landscape. Water and agriculture, for example, are considered separately. But more interestingly, or sadly, is that efforts to develop sustainable agriculture, sustainable water management, sustainable energy, and sustainable cities are compartmentalized. They're separate domains. They're not joined up. Silo thinking prevails. So this is pretty troubling. As part of the problem, the mindset, the organization of the production of knowledge. Now, what's fascinating is that permaculture, I believe, offers quite a different holistic approach that can integrate different parts and address some of these multiple crises. And panelists will invite us to think more holistically about land and water, and more specifically, they'll highlight how permaculture design can create regenerative, water-retentive, and resilient landscapes. So they're going to be talking about water, land, biodiversity, carbon sequestration, taking it as a whole rather as fragmented bits, and of course looking at the multiple benefits associated with a whole that is much greater than the sum of parts, and that's derived from the permaculture approach and the design principles that we'll be hearing about. So I'll close on that just to set the scene. There are big challenges in the water sector. It's very, very worrying, and we need a radical rethink, and permaculture offers part of the solution, I think, and we'll hear about that. So we will start hearing from Jay Abrahams, and then we'll turn to Andy Weir, and finally to Perrine Bulgheroni. I've asked each panelist to introduce himself or herself. You have the blurb in the document, but they may want to highlight other aspects of their lives. Jay is going to talk about applied permaculture design and water-retentive landscapes. Jay, you have about 10, 12 minutes. Yeah. Is that okay? Yep. Thank you.
Am I on? Yeah. My name is Jay Abrahams. I run Biologic Design, which is a regenerative or permaculture-inspired consultancy, and we create water-retentive landscapes. So, as was said about 500 years ago by Leonardo da Vinci, water is the driving force of all nature. So, obviously, we can't argue with that because he's quite a famous dude. So, bearing that in mind, that water is the prime resource, or the primary resource, because without water, we have no productive capacity in our life. All is dust and rock. So water is pretty important. So Bill Mollison defined permaculture as the conscious design maintenance of agriculturally productive ecosystems which have diversity, stability and resilience of natural ecosystems. So it's a bit of biomimicry, looking at what works in nature with 4.5 billion years of ecological intelligence, evolutionary intelligence. But the thing with permaculture is at the moment you look at the agricultural landscape, it doesn't have people in it. And with permaculture, people are harmoniously integrated into the design. They're part of the solution, not part of the problem. So it's a regenerative earth repair system capable, if done properly, of providing all of our food, water, energy, shelter and other needs whilst conserving the Earth's natural resources and enhancing them even. So, this is not really fitting, but this is a quote by Bill Mollison, page 9 of the Designer's Manual, this book, which I would recommend to everybody. What he says is there's nothing new in permaculture design. Permaculture directives just harness natural processes and alongside traditional and indigenous knowledge provide an answer for the future. The result of the adoption of permaculture design is to dramatically reduce the amount of land required by agriculture, therefore enabling current agricultural land mass to be rewilded in effect. Remember, he wrote this book about 40 years ago, so he was an early rewilder. So the design principles of permaculture design, which is what this whole book is about, and I must say when I read this book for the first time, I was working within the conventional wastewater industry, and reading this book I realised that I could use these principles to design regenerative wastewater systems. So I must warn you, if you read this book, it could be the end of your career, because it was with me. But the thing with this book, the principles of permaculture design were derived from this book by Kenneth Watt. He wrote this in 1973. It's out of print now, because it's very dense reading. But what Bill did, he looked at the first 14 of these principles of ecological science, and he turned these principles of ecological science into design directives. So if you use these design directives, you've got to get a regenerative ecological solution result. So those two books are the basis of permaculture for me. So in my work, we use these principles. We maximise the edge. So if you like, I have long, thin pools called swales, which maximise the edge between the water and the soil. So that interface between the water ecosystem and the soil ecosystem, an ecotone, is more productive than any other, than each of the singular ones on their own. So what I've done is we observe in nature wetlands are the most productive ecosystems. So we replicate that in our designed and constructed wetlands. In a design, we try and have each element of the design supported by more than 2 or 3 other elements, so that if one element fails, so a plant fails or a tree fails, it's got others to support it. And each function, and each element performs multiple functions. So again, a tree will provide a root zone, and in that root zone we have many microbes, and they're cleaning up the water. But the tree is also a habitat, and it's also maybe tree fodder, so it has many functions. I won't go too much into that, but that's there. We seem to be losing some of our what? Oh. Okay, that's the 3 strands of my work in biologic design. The first one is wetland ecosystem treatment, which is a regenerative wastewater purification system. Is that? No, I think it's actually on the slides. Okay, so that's what a wet system looks like. I like to say that sewage treatment never looked so good. We also do whole site water design. So that's when we took a field, and this is in pure sand and gravel, so totally permeable, and we created a water-retentive landscape, and that curvy line is following a contour. So that's a swale. And then we planted about 5,000 trees. The water for this wetland system comes from roofs, yards, and 2 springs. And even though we had a drought the year we had planted those trees, we didn't lose 1 tree because the site did not suffer from drought, because there was water in the landscape all through it. That's from the other view. And then there's a tree bog, which is something akin to a long drop, but there's no hole underneath. This is a tree-growing toilet system. It's a waterless toilet system. I've done them all over Europe. I've done them in West Africa and East Africa. It's a really simple concept. You have a platform-mounted loo seat. Trees are growing all the way around it. You have a rodent-proof container, little composting chamber is what we call it, underneath. So the feces, the urine go down. You have a pile of what eventually becomes humanure. The urine goes into the root zone of the trees. and everything grows really well. So here we have one that was done in Senegal, just to be planted, had no trees around it yet, so it's a double tree bog. And instead of using straw around the composting chamber, they use peanut shells because they need the straw for their animals, and peanut shells are a waste product. So permaculture uses what is there. So you start from where you are and you work with what you've got. This was one in Senegal. This was in 2019, December, we planted these. This was 3 months later. That was 6 months later. That was a year later. That was 18 months later, and the mango is already fruiting. Normally they take 3 years to fruit in Senegal. But because they've got all that lovely nutrient, all that lovely water, because they don't use bog paper in Senegal, they use water for washing. So all the water gets used again by the trees. 3 aims of a wet system: purification of water. This was a lab test done on a system that had been going for about 7 years at that point. We've got swale 1 at the left, and the bottom pool on the right is a natural swimming pool. So think about that. So a sewage treatment wet system where you can swim in the bottom pond, when you probably wouldn't want to swim in your rivers recently. Naming no names. The other, second yield is the production of biomass. So apples, pears, plums, trees, fruit trees, nut trees. Willow wands from the willow coppice. These are 2 sites making willow baskets. This was my mother's casket made out of my own willow by a basket maker who harvests the site at Hereford Market each year. And she's been doing that now for about 10 years. And she came up to me the other day and said, "Jay, I've paid off my mortgage using your willow and my baskets." I was really pleased about that. The third one is biodiversity, enhanced biodiversity through a wetland habitat creation. So there are multiple species. We don't just have reeds. We have reeds, rushes, sedges. That's good for wildlife, bees. We use P.A. Yeoman's scale of permanence in the landscape when we approach our work. That starts always with the most permanent factor in the landscape. So the climate is pretty permanent. I know we're trying to change that. The geography, the topology can be changed with diggers. The most important input to any system is to get the water sorted before all else. If you've got the water sorted, then your access won't wash away, because the water lines follow the contours, the access lines follow the water lines, the tree lines follow the access lines, which follow the water lines, which means your trees are being watered and they're easily harvested because you have access across it. And then you go on to build soil, ultimately. Is the aim of the whole thing is to build soil. Bill Mollison talks about an earth-water harmonic. That can be soil-based water retaining practices such as the chinampa, ridge and furrow, swales, ponds, pools, keyline ploughing, and then planting and mob grazing. These are all ways of holding water in the landscape. This is page 497 of the designer's manual, chinampa. So it's worth having a look at that, because the bottom one is actually a cross-section through a wet system. And the chinampa, has anyone heard about chinampa? Because they were developed by the Aztecs about 2,000 years ago, because the Aztecs lived in a shallow swamp, and in order to have dry land, they dug out the bottom of the swamp, it was only about 1 metre deep, and created islands. And those islands are where they had their agriculture, and these chinampa were so super abundantly productive that they were able to maintain a standing army. And I think the rest is history, because they took over the rest of Mesoamerica because of the chinampa, because of the superabundance they were producing. Keyline ploughing, I bought myself a keyline plough a couple of years ago, and that opens up, without turning the soil, it opens up, it lets air, water, and roots dig deeper, and that helps create soil. And this was 14 acres of highly compacted horse pasture. We keyline ploughed it, and within 2 weeks we had a bacterial soil, looking at the microscope, had turned into a fungal soil. And that meant that the vines, it's now a vineyard, could grow really well. This was a wet system we created in sand, which was the first one. There's the contours. You can see where the swales are there, following the contours. Harvesting water from at the bottom, it's high up, about 50 metres above the rest of the site, which is very level. And that's what it looked like just after the earthworks with the wood chip mulch, which we planted. That's what it looked like 4 years later. And that's a forest garden in Cheshire, run by a couple of families. And that's what it's like on the ground one early morning. And that's the top of the bank, which is gravel, and that was so dry, there was no water there at all. We put a lined pond in, which is fed by that 200 square metre polytunnel. That feeds the pond, and the pond then hydrates the whole of the land. We've got the veg beds on the right, and the forest garden on the left. This was the Adhisthana Buddhist community, which serves about 50 people all the time, and then sometimes there's 150 people on for Buddhist retreats, and then every year the Triratna Trust have a big global jamboree, and the site has 1,500 people. A machine would not be able to cope with that. That was the field when we started. That was the field 2 weeks later. That was about a month later after planting. That was 6 months later. Fruit trees went in. This was 2 years later from that blank field, which was just an arable field, totally smashed with tractors and pesticides. And that's the bottom pond, which is used every day as a natural swimming pond by the people who live there. And that's a winter harvest of the willow. And that's a lovely sunset shot. Yeah, so that's it really. I think I've just about stuck to my time, but I've handed out some notes which have some references and some links and things like that. So if you've run out of those, if you could take a photograph of them if you want it and take it. And my email's on there. If you want to get in touch, please do. So thank you very much. Yeah, there you go. Who's next? Andy?
Just make sure. All right. Got what you want? Is that enough?
That's Jay's.
Next,
Okay.
if you keep going forwards.
Is that it? Yep.
That's reassuring. Hi, I'm Andy Ware, Fernhill Farm down in Somerset. A lot of icons we have there because it covers a lot of the facets of what we try and achieve on the farm. At times I think we've set ourselves a very tall order of trying to do these things. As you will appreciate later on from some of the slides, we've worked very closely with Jay in actually putting into practice his wetland eco-treatment system to solve some of our problems. Our icons are hospitality, clothing, thinking, gardening, kind of pleasure sat around a campfire, and sheep. I've got a bit of a problem with sheep. I'm semi-addicted to them. We're running about 3,000. Hence why I wasn't here yesterday. We had to check water. That is the one problem with water in the system. When it freezes, it's a different item then. This is our farm up on top of the Mendip Hills. We are 800 foot up. It has been an industrial landscape 2,000 years ago. They were open cast mining lead. 3 years after the Romans landed in the UK, and I think it was AD 56, they had a garrison up on top of the Mendips. They then exploited even more. This has then led to the kind of the landscape being totally changed. Mining had carried on up there for a further several hundred years. Before we bought the farm 27 years ago, it had been topsoiled and turfed. So all the valuable asset of the farm had been taken away. But I'd come from a background, small family farm, spent 10 years on the road shearing sheep around the world, which gave me a great insight on the mistakes and the benefits of how you can and cannot farm. We have to all learn that we are part of nature and we cannot dictate to it, we have to work with it. I kind of entitled my kind of section here is Water Independence. I've learned how to shear sheep, I've learned how to work hard. I don't really like paying money out. So when you start getting bills for water, of which if you think about it, a 60-hectare farm which we have an average rainfall of about 1 metre, that's about 600,000 cube of water I'm collecting for the water agencies. They don't give me any money. We try not to pollute it. We're fully regenerative. So we're trying to increase our soil depth. There's no benefit. I could carry on and be a conventional farmer, apply sprays, apply fertilizers, and then they'd have to sort out the problem. Within about 5 miles of our farm, there's a couple of reservoirs, and you can see algal blooms through there in the summer months. So they have a huge issue, which we all know about. So I feel at some point in the future there should be a benefit to farmers who are farming regeneratively. So we've kind of gone in, we've got sheep shearing, hay sheds, we run open farms, we run hospitality for different events on the farm. We have mains water, which we're trying to reduce our consumption through that. We have a huge grey water supply off of rain harvesting, off of roofs. We've got solar thermal, PV, log boiler, which is, the log boiler is all burning home-produced timber, which obviously you need water to make the trees grow. We use a lot of willow, which again, we'll see some pictures of that, which up to between 3 and 5 tons a year are harvested from our wet system, so it's very cyclical. As you can see there, we've got 26 toilets on the site. It's not that I'm incontinent or anything, I need to just keep moving around the farm. We've got 9 showers, we've got 5 kitchens. So we find it is an essential that we can handle then not only the water input, but also the water output. All the dirty water that is on the farm is processed. But strangely enough, by the time we get to the end of the processing, we are now able to be a British crayfish conservation area. They need clean water. So in the final pond, we've got clean water. This is how we manage our soils, mob grazing, regenerative, by animal impact, saliva, urine, dung, move them on, everyday moves, you build your soil. You build your microbiomes in the soil which hold water for you. So the flock and the herd becomes the flood. Different times of the season, we can move them on. We've worked with Business 3LM to do EOVs, ecological outcome verifications. We're improving our water cycle, our energy flow, community dynamics. And it's changed farming into a chore, into a pleasure, and it's quite exciting every day to take on a new challenge. And working within that landscape, it's just good fun. And we're producing what we perceive as a very healthy product. As I said, we've got a wet system. We put it in place because of up to 20,000 visitors coming to the farm a year. We have events where there's over 10,000 people. Picture on the left-hand side of the screen, you can see the wet system in the middle. There's camping all the way around it. All that dirty water flows to a central point. We have to have a macerator pump. We've got to use a bit of fuel to pump it all back uphill again. The 6th pond, you can see, we're out there paddling around, canoeing. Beautiful, have 6 days of warm weather in June or July. It's actually about 25 degrees in there. It is amazing. You've got to pay quite good money to put in a swimming pool like that. And you can see a clear definition of the ponds, the wetland system. On the lower picture there, the swales, the willow growing. Huge diversity of plants, huge diversity of wildlife has moved in on that. The butterflies, the dragonflies, it's like a takeaway service for the swallows and the house martins through the summer months. And we have a huge water resource there. I think if you buy a bottle of water like that, it could be about £1. I've worked out we could produce about 7 million litres of water out of our wetland system by the time it takes about a year to get through. So I'm missing a trick somewhere. There's about £4 million worth to be made on water sales. So if there's any marketing people out there, please get in contact. I think we've got a little business project. And that concludes my little bit about Fernhill Farm and Andrew Ware. Thank you very much.
Thank you very much, Andy. That's great. So let's lower this. Perrine. So Perrine will be next, and we'll focus on permaculture water design at the farm Le Bec à Loin, which is in Normandy, France.
Yes, indeed.
Okay, let's work.
Just waiting for the presentation to be on. First of all, bonjour. Well, some of them shall work on their pronunciation. Okay, we do have a problem on this screen. Can we just see the words are cut here, Le Bec à Loin. We don't have the full wording. If you don't mind moving the projector. Sorry. I love when I get to command men. Good, thank you. I was focused to talk about the way we've managed water on the farm in Normandy. So Normandy, some of you might know, it's almost the same climate than you have here in the UK, in England, basically. Therefore, people tend to think we have a lot of rainfall. But still, when we first created the farm, that was more than 22 years ago, we didn't pay so much attention to water. At that time, we didn't know about permaculture, so our goal was to create a farm which meant production would be vegetables, and we would have some trees, sheep, chicken, and so on. Basically, the grandparents' old-style farm, and that was our dream. But since we didn't know about permaculture, we didn't pay attention to the design. Still, common sense forced us to manage water, because this farm is located right in the middle of a valley, a very small, narrow valley, where a stream goes by. We can see the stream up the picture over there. And that stream was redirected by the monks in 1100, something like this, because there's an abbey nearby. And for the purpose of bringing the water to the abbey, the monks at that time redirected the stream. Initially, the stream would have been right in the middle of the farm. So when we first started farming on this farm, we could see that, especially in winter, we had a lot of water stored at some points of the farm, and we wouldn't understand why. Basically, when we try to redirect nature, you never manage. The water would always go the same way. So we had to manage the water, not because of the fact that we needed water for the crops, for the vegetables, but because at some points we had too much water. That's why we started to think about the way we could collect the water. So one of the very first things we did on the farm was to dig ponds. And the water design, of course, as you might know, matters a lot. If you don't design the water, then you will have droughts, you might have floods, but especially in Normandy where we are, you might lose a lot of soil. And soil to us is the basic of everything. So addressing the water issue from day one was our priority. So we dig ponds, as I mentioned, we created swales. We wanted to have practices that would ensure resilient soil and ecosystems. This approach, the one we had first thanks to common sense and the one we emphasize thanks to permaculture principles, enabled us to create something that almost works by itself. The ecosystemic thinking behind the water design on the farm has been very successful because we've been somehow mimicking nature. Ponds, swells, those were tools that the ancient used to use, and when we started to create roads and so on, first thing we did, we filled them up. And we had no water retention, no water collection whatsoever. So first thing we did, again, without knowing about permaculture, we did pond. We planted a lot of trees. We didn't know yet that trees were the best radiators, the best climate or air conditioning system that could exist. And trees, to us, as farmers, are the best source also of nutrients collection. And they also stock carbon and so on. But trees were the things we wanted to have to be able to produce fruits also, but also to attract biodiversity. But we didn't know that trees would be the main tools for us to manage water. And of course, we were thinking about harvesting rainfalls, because to us, that was the obvious and the only source of water. But then we found out about permaculture and Bill Mollison, and that's one of his saying, if you only do one thing, collect rainwater. Without thinking about farming, without thinking about anything else, the first thing we shall all do is collect rainwater or address the water issue. What I mean by that is that our job as designer, as farmer, once you know about permaculture and the magical ecosystemic thinking of permaculture, you have to make sure that every single drop of water that will come in your system, your job as a designer is to make sure this drop of water will remain as long as possible in your system. So when you understand that, of course you've thought about ponds, about swells, but that's not enough. So how do you make sure water will remain as long as possible in your soil? First of all, you build the richest soil possible, a humus-like rich soil. So for us, because we are vegetable growers, it does make sense, because you might know that growing vegetables is the stupidest farming things on earth, because vegetables, you plant the seed, well, you sow the seed, the vegetable grows, it does absorb all nutrients and water as possible, and then you cut the head of the little salad and you export it. When you grow wheat or maize or whatever, you sow the seed, the plant grows, goes up until the end of its own cycle and goes back to seed. In the meantime, somehow the plant will give back to the soil, and also the microbacteria, our good friends in the soil, will give back to the soil whatever the plant has exported. Whereas with a vegetable, you don't do that. So this is completely crazy. So especially with our type of production, you have to build a humus-rich soil. We need a lot of nitrogen, a lot of other nutrients for the vegetables, but also to collect and retain as much water as possible. Another good practice is to maintain a mulch soil, a soil cover. Wherever you are in Mother Nature, you've never seen bare soil. The soil is always covered, maybe with nettles, maybe with grass, with whatever you think, but the soil is always covered. So mulch is your best friend in this type of system. You have to keep the moisture in. And the moisture is not only important for vegetables, the moisture is the best thing you can imagine to keep the soil life. For the bacteria, the fungi, you need the water, you need the humidity in the soil. So mulch is a very good way to keep humidity in the soil. It also protects the soil from the wind, from heavy waterfalls, from the frost and so on. So you have to keep your soil covered. and you're going to help the microbacteria also to develop. And basically, what you have to do on a farm, you have to think about the design, not only about the plots of land on which you want to produce, but you have to think about the water design. And most of the time, we think about the water we see, the raindrops, the stream, the pond. But the most efficient design when it comes to water is to design the water you cannot see. What is the water you cannot see? It's the water that is under the soil. And the water that is under the soil, how can you know that it is there when you start farming? We've made so many mistakes with that. We've planted many trees thinking they would thrive, but at the end of the day, they died because we didn't know when we digged the hole to plant the trees. After 1.5 meters, let's say, the roots would get directly into water when we had heavy rainfalls. Therefore, the trees were not happy there, and they just basically died. So you have to think about where the water is running, how is it running, how you think that under the soil it might come or where it might go, which is very difficult, and it takes some observation, it takes some experience to do so, but it is crucial, believe me. So if you adapt, well, I'm not going to go back to permaculture principles that you might know, and Jay talked about them very clearly, so I'm not going to go back on those, but basically all those principles go back to add organic matter and cover to your soil. You shall design water features, plant trees and shrubs. To us, trees are the pillars of the farm. Even though we are vegetable growers, we have trees and shrubs everywhere for biodiversity, for water retention, water collection, microclimate, windbreaker. The trees are the best multifunctional tools you can imagine. And of course, you tailor all this to your local climate and soil. Something that's very interesting and that's emerging in France at the moment, I'm not too sure if you have the same here, it's called the regenerative hydrology, and we have a few people in France at the moment talking about it. And they say exactly what I've been saying, which is you have to design the water, whatever activity you may do, of course for farming, but for other activities also. And the 4 R's for regenerative hydrology turns around receive. So first of all, you have to collect, to capture the water, whatever the form of the water is. And if you enhance the soil structure, then that's what I just said, you're going to collect it better and keep it as long as possible. Second R is recharge. So you shall, to be able to recharge, you shall facilitate water movement into the underground aquifers, which is, again, very difficult and technical to do, but it is really the main point and the key point to success when you design water. Third R, retain. Create ponds, swells, keyline design, as Jay explained. I'm not going to go back to that, but keyline designs are very efficient. We didn't do it at the Béquelin because more or less our land is very flat, except on some areas. But where we did it, it was very, very efficient. So instead of letting the water goes down to the slope, you collect step by step along the hill, you collect whatever water you can collect. And the fourth R is release. So if you want to manage water properly, you have to be able to catch it, to capture it, to store it, but you shall also let it go. It's a flux, it's a circulation, and you have to let it flow the way nature would make it flow. So you have to adapt your crops, your tree plantations, and maybe your cattle circulation and so on, to the flow of water. And it's not the other way around. You shall not force water to be efficient in your own system, but you have to do along the flow. You have to go with the flow of water, of wind and sun and so on, but especially water, because we know how difficult it's going to be in the coming years dealing with water. In Normandy, we've been farming, as I mentioned, for 20 years. Let's say for, well, 12 years, it's been okay to farm. Of course, when you farm, you deal with the climate, you deal with whatever the weather is going to be like. It's okay, it's part of the game. But for the last 10 years, everything has become hectic. And I would recommend to the people who are still a bit, unbelievers of the climate change, they should go farming and they will see how it is and how things have changed. And, I'm very anxious for the young farmers who set their own farms now, because not only they have to face technical issues, but they also have to face climate change issues, which we didn't have as a problem before. So we had time to learn how to grow crops, how to do things, how to do our job without all those problems. And now it's been, I think, 8 years since we didn't have anything normal. No normal season. You never know when it starts. We never know when it stops. When is spring, when is winter? Well, you approximately know, but you're never sure. So it's very difficult nowadays. So I keep on going with the presentation. So I think I mentioned all this. Soil health practice are the key to proper water management. Agroforestry also is one of the best techniques you want to use in such type of systems. So, of course, things haven't been that easy all the time. We had to overcome a lot of obstacles, especially when your soil is highly degraded when you start. So it might require extensive restoration efforts. We hardly had any soil when we first started. And I believe we spent more time creating soil than producing vegetables. So that was tough. We learned a lot. But we have to say that it is a tremendous obstacle, and you have to be careful about that if you want to set your own farm. The initial demand, when you want to create a proper water design, when you want to recreate soil, high labor, cost demands, please do not hesitate to put the money on the table at first if it is necessary. If you have to work a lot on your soil, on your design, do it. Otherwise, you're going to pay for that later on, and you're going to pay 10 times more. Climate change, I mentioned it 1 minute ago. For us, at first, it's been easy. It's getting more and more difficult. And also, you have to change your mindset, because most of the time I can still see nowadays for the young farmers to which I go to give them advice, they don't think about water design. They think about design because now they tend to know about permaculture, but when you tell them about water, they're going to measure how much water they need for their crops, that they can say. They're going to measure how they're going to deal in case of floods or heavy rains. But if you tell them about a global design for water, they're like, what are you talking about? So it's very difficult. It's still pretty unknown that this is the key point, especially in the coming years. So you have to do the design because it does pay off. Not only you do assess the risk and you address the risk your farm could encounter, but also you have many ecological benefits if you do manage your water design properly. Of course, economical advantages, and the social impact might sound a bit unsure, but still, when you create ponds, when you show people how you address water issues, you build awareness, you create educational opportunities. And most of the time, if you create ecological benefits and social impact, somewhere in the middle, it means you've created beauty. And beauty, everybody knows, will save the world. So, because we are all facing climate change, we have to address those water issues wherever we are on this planet, either in Normandy or in Africa. To me, it's almost the same fight, the same challenges. So we have to adapt. We have to scale the solutions because our farm is a micro farm. It's so tiny. You cannot say we've solved all the world's problems. We've just solved our problems, and that's it. And you have, of course, to align with global needs. I think that's almost the end of my message today. See, we've designed water on the farm. Also, I wanted to mention something else. Of course, we've implemented our solutions locally. We're trying to educate others and advocate for change. But also, at the end of the day, if you don't have fun, then it's not fun. And just like Andy, we've made our own water park, but just for the family. So this very large pond was there to collect the heavy rains, because that part of one field was always flooded in winter. We said, well, the problem is a solution, as we say in permaculture. Because it's always flooded, let's make it a huge natural swimming pool. And that's where we enjoy our summers. Even though droughts are there, even in Normandy, we can still go to that pond and enjoy the summer. I think that's it. I'll be happy to answer all your questions. Thank you.
Great. Thank you.
T'as besoin ou pas?
Ça va très bien, là. Tu peux le laisser. Can I check? Does this mic work? Yep, okay. Well, thank you very much, Andy, Jay, and Perrine. Very, very rich presentation, very solution-oriented and very inspiring. Thank you. And that's very heartfelt. It's great to see this. I'm going to open up by asking a couple of questions to our panel members, and then I'll turn to you for questions from the floor. And I'll take questions from individuals who are here in person, and I'll also have to check questions online, just alternating to make sure that we're fair to include people who are not here. I know you've said this in different ways, but if a journalist came up to you and said, why should small land owners and farmers invest in permaculture? What would you say, first and foremost?
What would I say? I should know, shouldn't I, really, why? My whole life for 32 years has been based on applying permaculture design principles, so I sort of live it. I've lived off-grid now for 40 years, so I live the life, and I try and create systems for people so they can do it as well. So why should they? I think because it's the right thing to do, I think. If you want to protect the earth and recreate regenerative systems, then permaculture is the only game in town. It's a very simple answer, I think, Michel. And there's nothing else, there's no other game in town, is what I should say.
Okay. Thanks, Jay.
Andy, when I approached Andy, I'd been to the Big Green Gathering, and I'd seen this bloke, it was Andy, I didn't know Andy at the time, going around in a tractor emptying all the turdices, all the little chemical loos. And I said, where's that going? And he said, well, we'll take it and put it in these huge big septic settlement tanks, and then we cart it down to Bristol. I said, that must be expensive. Yeah, it's about 20 quid a cube that we have to pay to have it removed. So I went home and I thought about it, and I thought, well, if he had a wet system, he'd save all that money. So I went back, and I don't normally go and sell my services. Normally people come and ask me. And so I approached Andy, and he thought, I think you thought I was nutter, didn't you? Because I said, can I rent an acre of your farm, and I will build a wet system at my own cost, and then I'll rent it to the Big Green Gathering, 20,000 people a year for 2 or 3 weeks on Andy's farm. So he looked at me, he said, you're serious, aren't you? And I said, yes. And he said, would it deal with this, this, and this, which is Andy's business plan, which is to have the camping barns and all sorts of people on site, courses and stuff. And I said, yeah, of course it would. He said, yeah, we'll have one of those. And he just went for it. And the result of him trusting his instinct was that he's now water independent. So that's hopefully answers in a very practical way why people should apply permaculture design principles.
Thanks, Jay. Do you want to add anything, Andy? Yeah.
I think it was very simple. Jay's alluded to it. It's a way of making money. It's a way of saving money. It's a way of feeling good about doing things within nature, natural ways. To take the dirty water off the farm was going to cost us about £1,000 a month initially. £12,000 a year, the cost of installing the wet system, the pumps or the pipes, everything else, was about £65,000. Payback approximately 5-6 years. Why won't you invest in something like that? I thought it was very easy. Permaculture design, a little less obvious, building soil through regenerative mob grazing. So you're taking or what can be deemed as waste product and pushing it back into the soil, feces, grasses, whatever the animals trample. You're building your humus level, so you're then capturing more water, so you'll be able to grow crops through the drier season, and it gives you more resilience in the farm. And I think it's that resilience, the robustness, and the pound working the right way for the owner of that land or the manager of that land.
Great. What's your perspective?
You know, I'm a great fan of innovation, so I love AI, agricultural innovation, and I think permaculture is the best AI you can imagine.
Great, thank you. This is a related question. Why would you advocate this permaculture design approach for water conservation, water management, over conventional methodologies that are currently used today?
Well, that's really easy in terms of, say, sewage purification. I think we're all aware that the sewage undertakers are failing miserably in their job, and with a wet system, you've got swimming pools at the end of a sewage treatment system. So I would say it sort of speaks for itself, really. And I am in sort of touch with Southern Water at the moment, trying to help them not pay as many fines as they're doing, maybe pay me instead. But yeah, they could definitely learn a lot from permaculture design. Unfortunately, the water industry is run by engineers, and I've got nothing against engineers, but these are chemical engineers, mechanical engineers, electrical engineers, civil engineers, but they're not biological engineers. So they're always looking at the switch, having the control to turn something on and off. But I looked at, when I used to work in the conventional waste treatment industry until about 1992, when I read Bill's book and decided that I would leave that industry. As I said, it was the end of my career. But I would say that, you know, if the water companies took on permaculture design, within a few years they could turn it around. But because they're mainly engineers, they seem very resistant to do it. So, I mean, I don't know why, but they are.
I think we'll come back to that, but I want to give you a chance to answer that question too.
I think as individuals, we need to take responsibility for our own waste. And that's what we've tried to do at Fernhill. It stays on the farm and creates a very valuable resource as well.
What was the question again?
It was, you know, why do you feel that permaculture design principles applied to water management are better than conventional methodologies currently used in France and elsewhere?
Yeah,
I was just repeating the question. Why are permaculture design approaches to water management better than conventional approaches currently used in different countries?
I think the very first advantage would be cost saving, obviously, especially on a farmer's viewpoint. But also, again, I'm coming back to the ecosystemic thinking that permaculture brings into our brains. And to me, that was a complete shift when I understood what permaculture was about. And again, I discovered permaculture after I started farming. So it was a complete shift in terms of mindset. And I do believe that if we start seeing things ecosystematically, we're not going to talk about waste anymore, because in fact, in a system, nothing shall be a waste. Every single resource that might be a waste, might be considered a waste, shall be reused for another purpose. I don't know if you heard about it, but in England, a few years ago, I think it's Southampton University. I've been in touch with researchers from this university because I'm a great fan of urine, and so pee is my hobby.
All right.
Well, we're not allowed to use urine in organic agriculture in the fields, but I think there's something there. And I was thinking, since we now lack nitrogen, we don't exactly lack nitrogen, but the nitrogen most farmers use come thanks to Russian gas. And as you might know, it's a problem nowadays. Nitrogen, the fertilizer that most farmers use, is getting more and more expensive. And, you know, I don't understand why we would go and find highly technical solution whereas nitrogen is everywhere, especially in our body, on our body, it's everywhere. And I'm like, well, the pee that we could, I think, easily collect everywhere could become the best nutrient, the best amendment for our soil. So we could create nitrogen-based fertilizers for farming based on our pee. It just needs a little few things to change to make sure you don't have hormonal leftovers and chemicals and so on in there, but it's easy. And you know, when for all those years at the farm, I used to create my own, what I call magical potions for the fields based on microorganisms and stuff. And I would always realize that whatever I was doing was generating heat. And I'm like, look, we've got pee that produces nitrogen that, thanks to the microorganism, can produce heat. How come we don't use those two things? So coming back to the University of Southampton, they invented something called the pea power, which is a very small unit like a pile that will generate power based on urine. And I'm working with them because I would like to have both electricity generation, but also at the end of the chain, I would like to have my nitrogen fertilizer. And I would like to set this unit in all farms, that the farmers would pee in their unit, and they would generate electricity and nitrogen. So it's not that easy because at the moment they don't manage to produce much energy, much electricity with that. But again, if we change mindset and we envisage everything, every waste as a resource, things would change.
Mm-hmm. Great.
I'm not too sure I answered the question, but
that's fine. Together you have, yeah. One last question. You started to touch on this, Jay. Obstacles to change. You know, you mentioned the engineers, their mindset, their way of, you know, seeing the world and acting in the world, all that. But do you see any other challenges that prevent these permaculture design approaches to water management being embraced by a larger group of people, by small landowners, farmers? I'd like to unpack that a little bit, because it's such a marvelous system, but why, you know, where are the blockages? Where are the disabling factors?
Everywhere.
Let's see.
The blockages, I mean, you go from the engineering mentality, the current paradigm, which likes the on-off switch, likes the ability to turn things on and on, being in control. Biology, you can't control. It's a free agent. It freaks engineers out, I think. But there's the planning system. I mean, it took us 2 years to get this through for Andy. I've just done a system on the Isle of Wight. It took almost 3 years to get planning. And this is, now people have heard about regenerative agriculture and regenerative techniques and maybe even permaculture, but it seems to be getting more and more difficult for me to get my systems out there, even though I've been doing them for 32 years and I've got about 250 in place, so I can show people that they work. But the planners are definitely a blockage, the engineering mentality. I say they're the two main ones at the moment. I think if we had a more ecologically literate population, then things would become much easier. So I think we need to start with education of people, kids, and young adults and adults, turning them on to the idea that ecological systems work. I think the ecosystemic thinking that Perrine was talking about is sadly lacking in the general population. And that obviously includes planners, people who make decisions, politicians. I mean, how many biologists are there in Parliament? 0. So that's a problem. I think we need more biological literacy, ecological literacy, and then things might begin to change. But unfortunately, yeah, as I said, it's getting almost more difficult to get wet systems in place than it was 30-odd years ago.
Really?
Yeah.
Okay. Andy, what's your take on that?
I think there's possibly, as Jay alluded to, education, making it a perceived route through to solving problems through contact with agricultural colleges. Permaculture is very rarely taught in the agricultural sense. Regenerative agriculture is still very rarely taught. I went to Reading, and it was all conventional approach many years ago. And I was one of the few that would stand up and go, I can't see that working long term. We've now reached the long term and we know it's not working. Peer pressure is quite strong. What might the neighbours say? Conventional farming is run maybe as grandfather did, as father did, so some will possibly do the same. And little by little I see that changing. We have many farmers come and visit our wetland system and kind of ask the obvious questions, so why did you do it? Is it saving money? And then they go away, and it still confuses me. 10, 15 years' time, they still haven't changed. And they're getting the bills from the Environment Agency when there is a leak into the river of some type of pollution. So I think it will happen. Policy needs to change, government policy needs to encourage it as well.
Thanks. Perrine?
Well, I think machines and more globally technology came to a point where human beings built walls between them and nature. Somehow, because we had the machine, because we had motorization, we thought that we need to know less about nature. I mean, less from an intuition perspective, because we have more knowledge now, intellectually speaking. But we know, most of us, we don't have this relationship with the nature, with the trees. How does the soil function? Have you ever tasted the soil yourself? Have you ever smelled a soil? And we've lost that contact. So we have to keep in touch with nature, but from a very childish perspective, very indigenous, intuition-based perspective. Because knowledge, only intellectual knowledge, is not sufficient when it comes to this type of issues. And the proof is that the more knowledge we have, the more we go to technological solutions. And the other AI, the other one, the artificial intelligence, is not going to stop that. On the contrary, we're going to go even further on that path. And to me, that's a problem. So reconnecting human beings to living elements, whatever they are, is one of the key, because the more we get to know about the elements, the more we're going to be able to observe them. Maybe not to interact, maybe not to act, basically. Maybe we're just going to observe and just stay still. But this connection is lacking, and to me, that's one of the problems. So you mentioned education. Of course, education comes first. And then money is the second problem, because if people were not willing to make a lot of money out of those systems, then we wouldn't be where we are.
Do you want to add something?
Oh, we've got 20 minutes. That's
Yeah.
And questions.
I was getting there. I was going to say, we'll leave it at that, and we'll hear from the floor and also people online in the next 20 minutes. We're dead on time. If you don't mind, I'd like to read out a question we've received online. We'll start with people online, well, at least one person, and then turn to the floor. So this is a question from Anthony, who's based in Norwich. I'll just read it out. Do the panelists grow any water bog plants as crops as well as for wildlife? For example, arrowheads, sagittaria, bulrush, cattail, or any others?
Yeah, we don't grow bulrush because it's so thuggish and takes over. But yes, it's got starchy roots and the seeds are meant to be edible. I don't fancy them myself, but yes, we do grow Sagittaria as well. And obviously the willow is a vast crop for sale. And also the willow on a couple of our sites is chipped every year and used as a mulch on veg growing. So yeah, we do grow those things, but we not bulrush. Okay. We never plant bulrush. It comes in on its own, and then we fight it, get rid of it.
Okay, that's a clear answer, Anthony. Who in the room would like to go first? Yes?
Farming question. Sold on permaculture.
Wait, can you wait for the mic? Yeah.
Practical farmer question. Sold on permaculture. Eventually we'll roll it out. In the intermediate stages, rehabilitating an old 50s commercial farm, breaking land drains, creating swales, trying to keep the water on the land. Problem, livestock-swale interface. Needing to use leaky dams to stop the swales in the deluges that we're having, overflowing and creating soil erosion. Can't leave the livestock anywhere near them because they love to wallow. Cows, sheep, who knew? And they destroy the leaky dams and they trample the edges of the swales and you end up with water running down the surface of your farm, which is what you've been trying to stop. Suggestions. Do they have to be fenced out permanently from the waterworks?
Yes.
Yeah. So you can't mix them at all?
No, because they'll just make a mess.
Yeah.
Electric fencing is the way forwards, and if you are putting swales in under some sort of agroforestry or silver pasture system, then portable hurdles or electric fencing is the way forwards, and then you're actually using your mob to create soil.
I've asked my tenants to keep their livestock out of the swales, and they haven't. So I need to now enforce that and be a lot more disciplined.
Yes.
Okay, all right, I'll quote you. That's very helpful.
Do you want to add anything?
And also raised beds and edges from which the cattle can find some feedings, because they will go to the edge, but they won't be tempted to go elsewhere. So once they have the food, they remain at that place. And the shrubs and the trees you're going to plant to feed the animals will retain the water and make sure the soil remain approximately proper.
Yeah. Andy told us he had lots of sheep, so maybe you have some words of wisdom here.
Following on from both comments, I think the mob grazing technique of a short, sharp grazing, move them on. That will invigorate more plants to grow. It will encourage their root penetration, and it will give more stability to your swales. Yes, initially there will be a problem. It's trying to get behind the curve rather than staying in front the curve of growth and the problem.
Okay, great answers. I'm going to turn to someone online, Claire. How are the areas around the ponds planted? Do they at times need to be planted as key wetland plants, as key wetland plants are absent from the surrounding landscape?
Well, every job we do, we go to the BSBI recorder of the area and find out what is acceptable and what is not acceptable. So we did one in Cheshire and they said you must not plant bog bean because it's rare and you can't introduce it. So we do that. We're aware of what is locally endemic and what is indigenous and what is required. And we plant up to 40 different species of wetland plant on a wet system. And that was because it gives, this stability from diversity is a permaculture precept. So we plant all sorts. We've got about 30 different sorts of basketry willow too. So again, we're planting a whole range of things, not monoculture.
Yeah. Yeah, working with that functional biodiversity is really important. Yeah. So Claire, I hope that works for you. Who else in the room, please? Yep.
Hello. I live in West Wales. I've got a small farm there, and it's very, very wet. My land is basically heavy clay, quite flat, saturated entirely for about 6 months of the year. And then we've more recently been getting droughts where it entirely bakes solid and dries out in the spring. And I just wondered if you had dealt with similar kind of situation and if you had any great, fantastic advice.
You might want to move. No, just kidding. We had terrible soil also when we first started. So it does take more time when you have such difficult soil. But there are things you can do on a very clayish soil. You want to make sure, again, you want to come back to your humus type of soil. So for your soil, you have to make it lighter. How do you make it lighter? Again, with organic matter, but a specific type of organic matter with lots of worms in it, and not too nitrogen rich, but not too carbon rich either. So you have to get in the middle. Some people would even go with sand in your type of situation, but I wouldn't recommend, because at some point it's not going to work. It's going to work for the structure, but not for the nature of the soil. Microorganisms are good, and as much as you can, you have to create places where oxygen will get into the soil, worms will thrive also, and you have to make sure that anything, trees, shrubs, plant, will be planted to absorb as much as possible. You might have seen the island picture also on the presentation. That would be quite a good idea, because it's fun, it's nice, but also it will enable you to take advantage of the clay, because, you know, when you dig a pond, step by step, you have to, I don't know how to say in English, but you have to clear the pond and take whatever is in the pond and use it as a fertilizer. So step by step, you can change also a little bit the nature of the soil in your pond and add it to your raised beds or wherever you're growing things. But again, the keys are rooting systems everywhere so that they can dig holes and let the oxygen and the worms do the job, and basically step by step change the nature and the structure of the soil. But it takes time.
Yeah.
Okay.
I would say if you've got a heavy clay, is it very rocky?
No, it's not.
Okay, so I would say do an initial keyline plough on contour, if you can, if it's not too steep. Mulch that rip. Plant it, mulch it, and actually put some deep-rooted things like sainfoin or chicory, which will have 1.5 meters deep roots, and that holds, as Perrine was saying, it holds that rip from the keyline plough open and allows air and the bacterial and the fungal stuff to go on, and that will actually create topsoil from your subsoil, and then when it rains, it's absorbing. So 5 inches of good organic soil will absorb 2 inches of rain. There'll be no runoff. So if you can generate soil, as Andy's doing, you're going to hold more water in the landscape for the drought periods. And you've plenty of water in Wales most of the year to take you over that drought period, I would think. So I do a little keyline plough with a planting, with the chisel-rooted plants, as Bill Mollison calls them, to hold that open, mulch it, and see what difference that makes over probably a couple of years.
Great.
Thank you.
I'm going to invite someone from the online questions. So Clara, she's asking, for speakers in the UK, how have you engaged with catchment partnerships in your area? CABA groups, for example. How have you engaged with catchment partnerships in your area?
Catchment partnership groups.
Yeah.
We've had to deal with catchment-sensitive farming, which is with the water agencies. Mm-hmm. So through our regenerative approach, we're slowing down the flow of water off the hill down to the lowlands, that then feeds into Bristol and Bath. If they're referring to like carbon capture, personally, we haven't got involved. I don't actually, it's not the word trust, I haven't seen it, a solid enough financial long-term principle being put into place. I think we need to all be careful about what we do with our own land, our own soils, on our own habitat. Get it right for yourself first until there is a large, strong movement any other direction.
Okay. Nothing to add? So that's for you, Clara. I think that's really clear. And then there were several hands in the room. Can I take the gentleman over here? We have another 10 minutes, so...
Thank you. I'll just keep it short then.
No, that wasn't asking.
Well, kind of two questions while I've got the mic. Can you explain the difference between black water and grey water? And in terms of inputs to a wet system, is there any difference? And then for Fernhill, you mentioned 26 toilets and 9 showers. Is there any difference with how you treat what comes out of those? So inputs and outputs.
Okay. So black water is all the wastewater from a dwelling. It's the sewage, the stuff from the sinks, the kitchens, the bathrooms, so it's everything. Grey water doesn't contain septic waste, so it just doesn't contain toilet wastes. Grey water can smell just as bad as black water can if it goes anoxic, because it's got all the oils and things from the kitchen in there, bits of old porridge and what have you. So, they're both pretty horrible if they go off, but if they're put into a wet system, and I don't make the differentiation between the two, I don't say, well, let's do something with grey water, do something with black water. All together, all in the wet system, all the nutrient is then absorbed by the plants. With the willows, you can cut it, chip it, and that is the mulch, so you're getting your nutrients back that way. But no difference between black and grey water in a wet system.
Mm-hmm. Following on from that principle, what Jay said, when we installed the system, wastewater or water with fuel in it, we want it all going into the wet system. So even on an event when someone is having a sneaky pee in the hedge, no, go and use the toilet. We want that fuel to come into our system. The more that goes into our wetland system, the more willow, the more plants, the more diversity, which creates its own fuel for the next lap, the more clean water that comes out the other end. Yesterday morning I was out with the telehandler taking water from the wet system to take out for the stock because all the water troughs were frozen up. So there is a cycle. The more water we can catch, the more security on water I have, leads to our water independence.
Mm-hmm. Okay. That answers your two questions. Great. Who else? Yes.
Oh, thank you. It was a really fascinating and very, thank you. Very inspiring talk. I teach students who are studying landscape architecture at the University of Sheffield. And I found a lot of what you've said very interesting, I think not least the challenge of how we think about what is happening in our towns and cities and then what is happening on a larger catchment area. Sorry, even though I do this professionally, I still can't say it out loud now. Anyway, I was thinking back to the opening plenary yesterday, where they were talking about this absurdity that we expect food to get cheaper and cheaper, yet at the same time, people in this country and elsewhere are going to face rising bills as all of the costs of our failing water infrastructure just get put on other people's shoulders, whilst dividends are taken and all of that. So my question is, what kind of progressive partnership and planning could be put in place that could help deliver on a catchment scale something that you have so beautifully brought to life?
Well, I think Andy said it. We've got to take responsibility for our own shit and clean it up. I hear people say, oh, well, they should do it for us, they should be doing this. Well, actually, whose shit is it anyway? That's my campaign. Whose shit is it anyway? If you take responsibility for it, and I've got several small, just germinating ideas of going to villages and saying, how about we go to Southern Water or Southwest Water and say, you failed us. We'll take your infrastructure under our own wing, we'll take command of it, we'll build a wet system, and we'll have a forest garden, a woodlot, using our own shit, whose shit is it anyway, and turn it into a resource, not a problem. So it just means, I think, people being ecologically literate, like I said before, and saying we will take responsibility for our own actions. And that's one of the precepts of permaculture too, is taking responsibility for our own lives and the lives of our children.
I think on that, we've forgotten that it is a huge resource. Grey, black, dirty water. As we've said, it is a huge resource. Local governments ought to see that as a huge resource and be able to turn that into productive areas, productive wetlands, productive tree growing, vegetable growing areas. I think a lot of it is they can't see the big business. They can't find the big business partners.
That's true.
And they won't.
Yeah.
Because it's got to be kind of local scale to make it work. We could intercept every drain line from every village and put in place these systems. So it's not that we're too late, we're still not brave enough to do these things.
Yeah, I think a lot of that has got to do with what I term scatophobia, which is the fear of shit, which is maybe down to potty training, you know, so it's basic, you know, oh no, but actually, as soon as you take responsibility, you realise it's not like, you know, nuclear waste. It's actually quite good stuff if it goes through the right process. Perrine?
No, I agree. I completely agree. And in France, it's been years since we've been looking for solutions. So when we first wanted to install a phyto purification system water on the farm, we were declined the authorization because they said you are too close from the stream. So, you know, they were fearing the fact that it could communicate. Nowadays, it's getting better, and individuals are more and more entitled to do such things in their own home. And the fact is, when you get to build a new house, it is now cheaper to install such type of system than being connected to the regular sewage system. So I think the economy, and I don't want to be cynical on this, but the economy will force people to go to savings. And you know, I put a very bizarre photo of a bucket on the presentation. I myself, in my own shower, I have a bucket. I mean, every single drop of cold water that I don't want to put on my body goes into the bucket, and the bucket goes back to the garden. Even though I've addressed the water problem in my garden, I'm very concerned about it. And I guess people more and more will be concerned, they will get into the economical problem, and they will solve ecological issues step by step. We're not there yet, but somehow it might be good that the water is getting more and more expensive and more scarce, because people will tend to pay more attention to it. I disagree with that, but somehow, you know.
Okay. Does that answer your question? Yeah. Thank you. The last question, then we'll have to close. I know you've been waiting for a moment.
I appreciated what Jay just said, and it's quite interesting. I'm with the Tyne River catchment, a big river in the northeast, which was clean and had salmon, is struggling. And I really appreciate the fact that we should be taking responsibility, and this is an evidence. So we have a problem in a lot of Britain that we have combined sewage. Basically, our rainwater off our roofs is topping up that system. So in the storms, when they're under pressure anyway, it's not because we're using the toilet more. And I said to the people in one of these activist groups saying they needed to challenge the water authorities, how many of you are actually collecting the water that your plants would prefer than a hose, that's being cleaned for you to drink, that then you feed plants with? And so I think there really should be a massive, massive campaign about how we design systems to collect and manage rainwater around our houses, even in urban structures, even if we design them so they look like bricks or something. But also the warning about that is, as soon as you start collecting water, make sure you know where the surplus can go.
Yeah, that's a really great idea to end on.
We can have one more. There was somebody just there.
Well, it's just we do need to close unless we're not going to be kicked out of the room immediately. Okay. So I just want to take the last 30 seconds to thank very much all the speakers. I think they've been encyclopedic in their knowledge and have shared with us in a very generous way big picture stuff as well as very detailed information about these systems. They're around, they have a lot to say, and they're very, very passionate about their work, so do make use of the fact that they're there. And thank you very much for joining us. Have a great afternoon.